Well, first of all, welcome. Thank you for coming. We are going to talk about Loom. Well, I am going to talk about Loom, and if you have questions about Loom, by all means, ask them. We have plenty of time. I mean, 3 hours is just fantastic to have all this time to talk about the subject and to deep dive in this subject. So if you came with questions, just ask them, interrupt me, make some noise, whatever. And the room is not that big, so it will be very easy to interact, and let us do that. My name is Jose. I'm this guy here. Rémi Forax is a friend of mine. I'm still giving him credit because we really created this talk together. We gave it together at Devox France a few weeks ago, 3 weeks ago. Also as a deep dive session. Unfortunately, Rémi planned to be there, but he couldn't make it to London today. So, well, you'll have me instead of both of us. Okay, so my name is Jose. I work at Oracle. I joined the Java platform group about a year ago. I used to work at the university in Paris, and I did that for 25 years. I taught Java technology for quite some time. And here is a set of links that you can follow if you feel like getting content on the web that I produce. If you don't like to be spammed on Twitter, you can follow me, and you won't be spammed, I promise. I also have stuff on GitHub, YouTube, SlideShare, etc. And this is the slide by Rémi. So Rémi is this guy. Maybe some of you already know him. He's also a Java champion and a Java One Workstar. Well, technically speaking, because I'm now working at Oracle, I'm a Java champion alumni, because you're not allowed to be a Java champion if you work at Oracle. And here are some links that you can follow if you want to follow Rémi. Rémi doesn't have a Twitter account. So it's not, his Twitter account is not Nope. It's just to tell you that it doesn't have one. He has a GitHub account that is extremely interesting. And if you want to get content on Loom and other stuff from the JDK 17 and later, whether it's on the Ember project, Panama, Valhalla, all this kind of thing, you can definitely come and visit his GitHub account, because there are a lot of content and a lot of resources on all these subjects. By the way, we will be doing a Java 17 pattern matching, records, seal types, etc. lab tomorrow with my friend David Delabasset here at Devox UK. So if you're interested in other subjects than Loom regarding the JDK 17, you can come and join this lab. All right. Along with the release of the JDK 17, we also launched a website with the Java platform group called dev.java, which is the basically, in a nutshell, the I would say official documentation of the JDK, updated to JDK 17 and JDK 18. There is quite a lot of content behind that, something like 1,000 pages if you print everything. So don't do that, please. I think it's pretty useless to do that. And we also have community pages where you can find information on Java user groups and the Java Day stuff that is touring all over the Java user groups all over the world. If you know a Java user group, or if you run a Java user group and are not referenced on this page, by all means, send us a note, send us an email, and we'd gladly add you to the list. I think that currently we have more than 450 Java user groups referenced on this page, which is just amazing. It's really fantastic. And along with that, we also have inside.java website, which is more a curated list of blog posts. There is a podcast also that you can listen. It's all technical. The podcast is a set of interviews of the people that are really working on a JDK, developing the new features that you may like or don't like, but the new features. Anyway, and so if you really want to get the information from the source, this is definitely the site you want to connect to. Great. And I would like to also advertise a super event that is going to happen at the end of June in Edinburgh. I don't know if some of you have already attended open space conferences, but if you have not and are interested in technical discussion and this kind of thing, you may consider joining this kind of event. It's really the topmost event that you can imagine. And by the way, I'll be there too, because I love open space conferences. All right, so that was for the introduction. Loom. First, I would like to begin with a word of warning. Loom is still a work in progress. Okay, it has not been released yet. We will have a part of Loom available as a preview. Oh, there's plenty of room in the front, so yes, by all means. So we will have a first part of Loom, the virtual thread part, as a preview feature in the JDK 19. It doesn't mean that everything is stable, doesn't mean that the APIs are stable. There may be some change in the future that will come up. So I'm going to show you the state of Loom as of today. It may change in the future, but I guess that the main ideas of Loom will stay the same. So at least in the principles, what you will have is what we will have in the JDK in some of the upcoming versions. So the virtual thread is a preview feature. It's the JEP 425. All right. The effort is Excel. You can see it. Just to give you a glimpse at what Loom represents on the Java virtual machine, this is the pull request on the JDK source code, right? Almost 100,000 lines of code have been changed, modified, added, or deleted over more 1,000 files, which is huge. By the way, this pull request has been done. As of now, it's done, so it's in the JDK and should make it as a preview feature. All right. If you want to download, we were talking about that just a few minutes ago. If you want to download an early access version of Loom, you can connect to this link. All the demos I'm going to show you are using the last version that you can get from this link that has been published less than 2 weeks ago, 10 days ago, about. And so you can just put your hands on it, and if you want to try things yourself, help run things, bench things, your own applications on this kind of stuff. Yeah, question? How complicated is it to test it in your application? Really, I don't know because I don't know your application. But what you can download from here is just a zip file with a JDK that is not a JDK because it's not an official version JDK, etc. But it's a drop-in replacement of the JDK with Loom in it. Okay, so it's a JDK 19 Loom early access. Okay, and if you use it, you just unzip it somewhere, and you just tell your IDE or your Maven or your CI/CD, hey, this is the JDK you should be using to build a project, and you will be able to run your project with that. And I will show you some of the features of Loom. In fact, the JDK itself running on top of Loom is already leveraging some of the features of Loom. So even if you don't touch your application, even if you do not recompile it, you will be able to see if you can gain some performance improvements with that. But if you go a little further and I'm going to show that to you. Okay, I'm going to show that to you. Other questions? By all means, if you have questions, just raise your hand and I'll gladly try to answer them. So before we deep dive, Loom is about concurrent programming, okay? Who thinks that concurrent programming is an easy topic in Java? Oh, one hand. Congratulations. Well, I taught concurrent programming for 25 years, and I never thought it was an easy topic for the students to understand. Okay? Concurrent programming started with the very early versions of Java. This is some Java 1 code, okay, 1995. All right, quite a long time ago. This is a runnable. This is the model of task we had back in these days. We didn't have lambdas in 1995, so you had to write, well, you could write that in a class, in a separate class, but here it's an anonymous class. You remember instances of anonymous classes? Yes, this weird syntax, nobody really get it, okay? And then you pass this task to a thread, new thread. Oh my God, don't do that. And then you start your thread, and if you don't start it but run it, it will not create a new thread, in fact, because calling new thread doesn't create, it creates a new thread object, but if you call run, this thread is not really created. It will not run your task. Your task will run in the main thread. If you call start, then this thread will be started with the task as an argument, and your task will be run in another thread. And if you want to see the effects of that, you need to call join, because if you don't, of course, the main thread will kill the JVM before the other threads had any chance to run. Yeah, that's 2 or 3 things on concurrent programming. The book you want to read at that time is the book by Doug Lee, probably the first edition, Concurrent Programming in Java. Great. And to synchronize your code. Now, synchronization is a tough topic. It was probably easier in 1995 when you had only one CPU and one core in your CPU, rather than now when you have multiple cores and multiple CPUs and this kind of thing. But the basic pattern is this one. Synchronized on an object. Every object in Java has a special stuff called a monitor. Synchronized will take the monitor, and then only one thread can execute this block of code. Right? This is the model of concurrent programming in 1995. Let us jump to 2004. 2004 is the release of Java 5. And in Java 5, there is a whole new API called the Java Util Concurrent API, also developed by Doug Lee, with a bunch of new stuff in it. And the first new thing is this new model for a task. Okay. In Java 5, we also have generics. Yay! Parameters types. Great. But if you want to create a new callable, you also need to specify the type here. The diamond operator is the Java 7 stuff. So in Java 5, this is Java 5 code. And we also have annotations in Java 5, by the way. This is also a new feature. A callable is a new model for a task. What's good with the callable is that it can talk to you. Okay, they give the task can speak actually. It can return a value, okay, and it can throw an exception. A runnable cannot. So that's great. So now that this callable returns a value, we need a way to get this value from one thread to the other. All right, we see that. The book you want to read at that time, and you still want to read that book because it's probably the last book that has been written about Java concurrency as of now, is Java Concurrency in Practice by Brian Goetz. Okay, great book, really. No doubt with that. Normal threads, well, you can still create your threads by hand, but the best pattern is probably to create an executor service. Okay, executor service is an interface, and you have this executors factory class with a bunch of factory methods in it, with plenty of methods to create as many, well, to create the executor service with the thread policy you want in it. And then when you submit a task to an executor service, this submit will return a future object to you that acts as a bridge between the thread that is going to execute your task and the thread that launched your task. But this is still a blocking call. This is not blocking call, but once you want to analyze the content of this future, then your code will be blocking, which is an issue, of course. So you shouldn't, as of Java 5, you shouldn't create threads by hand anymore. You shouldn't call new thread by hand anymore. Why that? Mainly because, in fact, a thread is quite an expensive object to create, and we're going to see that. This executor service has a waitlist. It has only one, so if you submit tasks to it, they will be added to the waitlist, and when a thread is available, it will take the task that it needs to run, and it will execute it. Okay, how can you do some, these are the patterns you can use to get the result from a future object. You basically have three ways to do that. Get with the timeout, and cancel. Great. And then you have a bunch of primitive stuff to do some concurrency, to handle concurrency and synchronization. The first thing you have is you don't need to call synchronized anymore. You have this lock interface with reinstall lock, that's the implementation, and this is the pattern you can use to synchronize your code. In fact, this piece of code will be synchronized. And the question at that time is, should we be using synchronized or lock? And the answer in Brian Goetz's book is, well, if you don't need all the feature brought to you by lock, you can still use synchronized. It's almost the same. We're going to see that this has changed with Loom. You should stop using synchronized any way you can. And you have many more concurrent classes: semaphore, barrier, count, and latch. This is to do synchronization and stuff. Blocking queue, concurrent map, and copy on write lists. These are collections, well, thread-safe collection implementation. Well, implementation of collections and map for a concurrent map, of course. Well, concurrent map, technically, it's an interface, but you have concurrent hash map that implements that. Okay? And then we have 2011. I don't think, but there's some kind of pattern here. 1995, almost 10 years after Java concurrent programming, and almost 10 years after that, 2014, Java 8, and the last stuff. And we are again 10 years after that, 2022. Java 18 is almost, Java 8, sorry, is almost 10 years old. So it seems like every 10 years there's a new stuff in concurrent programming. And in these two versions, we have a framework called the fork join framework. We're going to talk a little more about it because it plays a role in Loom that allows you to compute things in parallel. Now, I don't know if any of you ever wrote some code against the fork join framework. Yeah? Was it easy? Was it enjoyable? Was it easy to debug? No. Well, you can still use it. I mean, it's possible, but probably parallel streams are a little easier to use. Just call parallel, and it's supposed to be working. This fork join framework relies on a special piece of code called the fork join pool, right? And this fork join pool it's a pool of threads. So you could say, oh, it's kind of the same thing as an executor service. The main difference between executor service and a fork join pool is that in an executor service, you have only one waitlist for all the threads, where in a fork join pool, you have one waitlist per thread. If you have 8 threads, you have 8 waitlists in the fork join pool. And there is a special mechanism that is, by the way, described in Brian Gates' book, which is called the work stealing stuff. That is when a thread has its waitlist that is empty, it's able to go on and check the other threads, see if there's some work to be done there, and steal a task from another waitlist. This is called work stealing. Okay? And we are going to talk more about that also. And in 2014, Java 8, we also have this amazing API called completion stage. Completion state, that's the interface. Completable future is the implementation, right? Completable future is a subtype of future, and it allows you to program stuff in an asynchronous way on a JDK. Okay? Who wrote some code with completion stage? Yeah, many of you. Was it enjoyable? Yes? Oh, was it simple? After some practice, it's becoming... yeah, after some practice, yeah. After some practice, yeah. You need to practice it. Yeah. I agree. Was it easy to debug? Not so much? Okay. What is really nice with this model is that you can really create your pipelines of tasks. You have a nice model to handle exceptions. You can recover from exceptions. You can also control which thread or which pool of thread is going to execute your tasks. There are many features in it that are really nice. But I wouldn't call this API a simple API. It's quite complex to master, I think. No? Sorry? Over 60 functions. Oh, yeah, 60, yes. There's a lot of methods in completable future. And there is also cyclic dependency between the interface and the class. All right. There is one thing that stayed the same over the past 25 plus years, is that once you have given a task to a thread, this task is stuck to the thread. Okay? And that never changed. If you give a task to a thread, either you interrupt the thread, and it should interrupt the task, either this task completes with an exception, either it completes with a result. But there's no other outcome. So if you want to have multiple tasks, like many tasks, then you need to have many threads. And this is an issue because a thread is not a free resource. Okay? And this is exactly, I mean, I think that if there's one thing you may remember at first with Loom, is that this is the exact thing that is addressed. Now with Loom, you can break this strong dependency between a task and a thread. You can remove a task from a thread in Loom. Okay. 2023 plus the Loom project. Great. What is Loom addressing and why do we need concurrency? Concurrency is a hard topic to teach, I can tell you. It's a hard topic to understand. All these race conditions, synchronization, all this kind of stuff became even more complex in a multiple world in which we are living. Why do we need that? Well, we do need that mostly for computations and input-outputs. And these problems are very different problems. Okay? The first context of concurrency is, I wouldn't say parallel computing, because parallel computing is another topic, like SIMD stuff and this kind of thing. I would call it computation in parallel, which is different. Okay? Parallel streams. What do you need to do when you have parallel stream? You take a task, a big one, like you want to sort a huge array or something. And what you're going to do is you're going to divide this task in several chunks of data. And you're going to process each chunk of data on its own core of your CPU. If you have 8 cores, 12 cores, that's all the best. You will be able to divide it in as many chunks as you have cores. And each of these cores is going to compute its own part of your data. And then after that, you will need to merge the result in a certain way. This is exactly what the fork join pool is doing. The forking is you take your chunk and you fork it on the different cores. And then once this computation have been done, all the results will be joined into one big result. The problem you have when you do that is an algorithm problem. If you do a sorting, for instance, if you do it in just one chunk of data, you are going to launch your quicksort, enhanced quicksort algorithm on this data. But if you want to divide this among the cores of your CPU, then you will have a quicksort on each of the cores, and then after that you will have a merge sort to merge all the results. So this is an algorithm problem. Okay, if you have I/O in a stream, which is already an issue for me, you shouldn't be doing that, and you try to go parallel with it, you will not gain any kind of performance. You will lose performance, because this is not what parallel computing is about. Okay. Now, the second, in this kind of context, you see that having more threads than cores is completely useless. It will just be an overhead. Because if you have 20 threads and 8 cores, your thread scheduler will have to say, okay, I need to share the cores among the threads, and it will have to switch from one thread to the other on the cores. And this will be an overhead in your computation. If you check the common fork join pool, for instance, which is used by default to handle parallel computation in the Stream API, you will see that it adjusts the number of threads on the number of cores you have on your computer. And it should be done in that way. Okay? This is the computation in parallel in memory. Your problem isn't a problem of algorithm. And you don't need more threads than you have cores. When you're doing I/O, now things are completely different. Because each task is bound to a thread and cannot be taken out from this thread, once your task is waiting for some data from your network or your disk, your hardware, whatever, okay, it will have to wait. Your thread is blocked, it doesn't do anything, it's not doing anything, it's just waiting for the data, and you can't do anything with it. Okay? Think about an HTTP server, for instance. This is what is happening there. Now, suppose you have a thread and you're doing some kind of request on a server or on a database. You have 3 phases, basically, in this thread. The first phase is preparing your request. This is in-memory computation. So you are going to execute that in the order of the tens of nanoseconds, maybe 100 nanoseconds. All right? And then you launch the request on your network, to your REST server, to your database, whatever. And this is going to execute in the order of the millisecond, because this is the speed of a network. It hasn't changed in 30 years. Not much, at least. All right? There is a factor of 1 million between this and this. So this is not at scale, right? This should be less than a pixel. But I want to see it, so I just enlarged it. And then you will get the response of the server, and that's another in-memory computation in the order of the nanosecond. So basically, you have three phases with two categories of phase, I would say. One that is executing in the order of the nanosecond, and the other in the order of the milliseconds. You have a factor of 1 million between both. All right? So how many threads do you need to keep your CPU busy? Because during this time, your CPU is not doing anything. It's just waiting. 0%. Flat. How many threads do you need? 1 million. Right? It's probably less than that because you will have some overhead to do the switching, but it's in the order of 1 million. How many threads can you run on a machine? Well, it turns out that when you bench stuff, you will realize that threads are not super cheap. A thread is an operating system resource, right? It takes about a millisecond to start a thread. So if you have 1 million, it will take something like 1,000 seconds. Let's say 20 minutes. Yeah, maybe a little less. 20 minutes. 15 minutes? Okay, 15 minutes, fine. When you create a thread, you have to reserve the stack. On a Linux machine, for instance, upfront, it allocates 2 megabytes of data. So if you want to have 1 million, that's how much memory? 2 terabytes? Something like that? How much memory do you have on your computer? Do you have 2 terabytes? Well, I don't, but I guess it does exist. And when you want to switch from one context to the other, it will take you about 100 microseconds. So if you really want to launch 1 million threads on your Linux machine or server, it will take you something like 20 minutes. When you want to switch from half of this thread to the other half, it will take you like between 1 and 2 minutes. And you need 2 terabytes to run them. Okay? Do you think it's possible? Yeah, the answer is just there. How many threads can you run on a real computer? And this is the funny part, I'll tell you. Because this is the demo Remy would have done to you because he has a MacBook. He's a rich person, so he owns a MacBook. Okay, and the limit, say the idea is to create threads in a loop and run them and do something with them. And you try to run as many as possible. And when you reach 4,000 plus, you get an out-of-memory error. This is on macOS. All right. And this is on MacBook with 16 gigabytes of RAM. And we tried on the MacBook with 32 gigabytes of RAM. It's like in the order of 6,000. So it follows the amount of RAM you have.
I think probably with the process limitation, it's not related to the RAM.
Well, it still allocates 2 megabytes up front.
But I think probably hitting the process limitation, that's why it's unable to create native images.
Oh.
There's still limitation, but I think this one is most related to the process limitation, because in Linux and in MacOS, I think there is for each operating system user, there's a default limitation for processes to not kill the server.
Oh, I see what you mean.
You also have a virtual memory also, so depending on, you don't get 16 actually, you get a bit more, but depending on, including virtual memory.
But okay, we need to gain a factor of 1,000 there, so we are far away from that. Even if you raise this limitation, you still need to go much beyond that, right? Okay, I'm going to try to show you how it's going to work on a PC, because I have a PC. I'm not rich as Remy is. Okay. I'm using some patterns I'm going to show you in a minute, but this is creating a platform thread. This is not a pattern. This is a pattern from Loom. Okay, so we are going to see that, and we are going to create 2,000 of them. I'm just going to put them to sleep for 2 seconds, okay, and print the duration. So I don't expect that, and I have only 100 threads. So I don't expect that to run for more than 2 seconds, right? Because basically these threads are doing nothing. So how much time will it take? Yeah, okay, 2 seconds, great. Kind of working. Let's raise to 1,000. It should still be 2 seconds. Anything over the 2 seconds is overhead, because basically what I'm doing is only put them to sleep. Okay, 1,000 working. 10,000? Remy's MacBook would be crashing there with 10,000.
It's Windows or it's Linux?
It's Windows. 3 seconds, 3.6 seconds. So it means that we can begin to see the overhead, right? I wouldn't dare going to 100 because I did this test before. We are going to just do it for 50,000. Sorry. It should still take 2 seconds. Well, apparently it's taking a little more. I don't think you can hear the fans, but yeah, I can tell you that the fans of this PC are spinning harder. Oh, well, it worked. 50,000, 20 seconds. It means that to launch 50,000 threads, I have about 18 seconds of overhead, which is quite a lot. I don't know if, to be honest, I don't know if it's a lot, but clearly reaching 1 million, I wouldn't even try to do that because it will not be, even if this machine can launch a million threads, it will not be usable. That's the problem. Yeah?
But then, because you only dive after 2 seconds, or if you want to keep all of them running, then it takes you the timer.
In fact, when I create this thread, it's unstarted. I start them in a loop there, okay, and then I'll join there. So they are supposed to really be running.
Yeah, but after 2 seconds, the threads are going, right?
Yes, they're dying.
So that's why even though you're doing 50,000, they're not all running parallelly because some of them are.
This is why I'm launching them in that way. This is when I say it's something we set up with Remy together. But yeah, we are starting them as fast as possible so that they all have been created. When you begin to run that, they all have been created already, and we're just starting them as fast as we can, and then joining them to make sure that when we leave the stuff,
I didn't see that.
yeah. So it's yeah. It should work, but I mean it's clearly not working. If this is your point, we agree on that. All right. So launching 1,000. Sorry, I need to quit this because if I don't, I will be in trouble when I come back. Don't worry, we get back to the IDE. So basically, what you can run is in the order of the tens of thousands of threads. I'm talking about platform threads on a, let's say, regular machine. So what are the solutions? Solutions so far is basically the same name. It's called asynchronous programming. All right. Is asynchronous programming a good solution? Well, probably. At least it has been as of now. We've been using it. What may be the problems with asynchronous programming? There are still several problems with them. First, it relies on the breaking of your problem into stages, into small stages as small as possible so that you can write them in lambda expressions, mostly, and then execute them in pipeline. This is how completable future is working, and this is basically as everything else is working. If you look for callback hell on any kind of good search engine, you will see what callback hell mean, and you will see what kind of code people are writing. No one in this room is writing this kind of ugly code. I know that. But you will see what other people may be writing when you call back and call back and call back and call back again. It makes your code super hard to debug for one good reason. Well, for one reason, I don't know if it's a good one, which is you're losing the call stack. When you're in a Lambda and you're analyzing the call stack in your debugger, what you see is basically your framework, whatever framework you're using. But you don't know where you are exactly. And I'm going to show you call stacks on that. It's super hard to test. You can test each Lambda individually, but testing them as a pipeline, It's just a nightmare because if you want to write a JUnit test, you need to be careful with visibility and this kind of thing. And your test may fail just because of race conditions. Because you need to test the value your pipeline has produced in the same thread as the one that produced it, which is not that easy. And it's also very hard to profile. Anyone try to profile any kind of asynchronous application? No? Yeah? Were you happy with the results?
So it depends on for async profiling, etc. For displaying graphs, it shows
Yeah.
quite good, so in general it's easy.
Yeah. If your asynchronous application is too slow, what are you going to do?
Basically, if it's pointing to the exact method, which part is the slow, okay, you need to investigate how the
Yeah, that means that you know what is slow in the stuff. And if you don't see what is slow in your stuff, and it's your framework that is slow, you're in trouble. Yeah, we agree on that. We agree on that. Loom is meant to address all these issues. All right? The first thing we're going to talk is about the model of virtual threads. We're going to talk about that. And after that, we'll be talking about structured concurrency, which is the programming model you'll be able to use once you have Loom installed in your application and once you have these virtual threads running in your application. So first of all, this is how you can start a platform thread using the classical JDK. Okay, this is Loom code, but it's basically almost the same as the code of Java 1, the first version of Java. The only difference being the Lambda expression. Virtual threads are almost the same pattern as platform thread. This is how you can launch a virtual thread. Okay, you have this factory method on the thread class that you know, all right, and you just pass a runnable to it, and you can call join just to make sure that this task has been executed. Okay, I'm going to show that to you because we have an IDE, so we should definitely. Yeah, question?
Yeah. So I saw that it started it created it and started it.
Yeah, at the same time. If you don't want to start it, you can also do that. I'm going to show that to you. So let me go back to presentation mode. So this is just a thread. Okay, I can run this code. It's running correctly, and you see that this is the 23rd thread, main blah blah blah. That's just basic code. Now I'm going to make a virtual thread. So thread dot new start virtual thread. I'm going to pass the exact same task. Display thread.current thread, because it's nice to display thread.current thread. And this is going to be, this is a thread, by the way. Okay, I'm going to call it vthread. And I'm just going to copy this, that, take this, and put a v, and that's it. Okay, so that's the pattern to create a virtual thread. Super simple. And it's still a thread, because the virtual thread class extends thread. Note that this virtual thread class, you don't see it. And it's meant to be in that way. You don't manipulate this class directly, you just manipulate a factory method. So in the future, if the people want to change this class, you will not have to change your code, which is much better. Now, what is going to happen if I want to run this code? This is a preview feature of the JDK. And if you want to play with preview feature, you need to tell it to your JVM and to your compiler. Okay, so you cannot, in a JDK, use a preview feature by accident. A preview feature is something that may change in the upcoming versions of the JDK. So if you use a preview feature in production, it means that it will have to be refactored probably when you change your version, and you don't want that. Okay, so if you want to use preview feature, you need to say it, you know that you're using them, and you shouldn't be doing that in production. So I'm going to enable the preview features. Just copy this stuff, open this stuff. Yes, I want to add this VM option, apply, OK, and run again. And now, oops, what did I do? Oh, yes, it's already started, so I cannot start it again, of course. So now I can join it. Okay, so that's my virtual thread. I put platform, come on. Nobody told me. So that's my virtual thread. All right. So first, a virtual thread is a regular thread class-wise. So you can use everything you know about the threads applies to virtual threads. All right. So that's from the programming model. That's really great. Now, what do we have here? We have the number of this virtual thread, 24. That's the 24th virtual thread that I'm launching on this virtual machine. So it means that with Loom, the virtual machine is already leveraging virtual threads. There are already many things that are run in virtual threads that used to be run in platform threads in the previous version. So all the performance gains that you can get from virtual threads, you are going to gain it at the JVM level because of that. Free performances. Second point, you see that a virtual thread is running on top of another thread, fork join pool 1, worker 1. Fork join pool. That must remind you of something, right? We already have a fork join pool in the JVM, in the JDK, the common fork join pool. This is another one. This is also a fork join pool. It shared the same feature of the common fork join pool, which is you have one waitlist for each thread in it. And it also is a pool of platform threads called worker 1, worker 2, etc. Okay? When you display a virtual thread just by printing this, you will see the virtual thread itself and the platform thread it's running on. In fact, a virtual thread is something that is running on top of a platform thread. Okay? But you do not launch platform threads yourself. Platform threads are launched by this fork join pool. Okay? This fork join pool has a difference between with the common fork join pool. The common fork join pool has the stacks in it are first in, first in, first out. So when your parallel stream is adding a task on the stack or adding a task in a waitlist of a thread, you want this task to be executed first. In this fork join pool, it's different. It's the opposite. When a task is added to the stack, you want it to be executed first. What did I say? I said the contrary. Sorry. Okay. Let me rewind that. When you ask a task, you want the last task to be added to be the first to be executed. In a common fork join pool, you want the contrary for the fork join pool of the virtual threads. Okay. The oldest task should be executed first. All right. Yeah? Sorry, can you say that again?
Is there a difference between platform threads with and without Loom?
No. A platform thread is the same. A platform thread is a platform thread, whether you're doing Loom or whether you are doing... here I'm doing Loom, right? And I'm creating the first thread I'm creating is a platform thread. It's not a thread from the fork join pool.
So the example with the 60 GB Mac is otherwise. Both were platform threads regular.
Absolutely. For the previous example on the Mac and the PC that we just saw were with platform threads. Absolutely. Yeah?
Can you give an example of where virtual threads are being used in the JVM?
I cannot show that to you. I will show that to you at the end because I will show you a thread dump of everything, and we'll see that at that moment.
I have a question actually. So in the virtual thread, if you rename the thread, will it stay on the virtual thread or does that change?
If you rename the thread, what do you mean?
If you set the name of the thread, there are a lot of
You can set any name you want.
but because if it, let's say, because platform thread could be running
Yeah.
virtual threads, right? Because
Yeah. We're going to see that. We're going to see that. We are going to launch the thread. So that's what I wanted to say you. Okay. How many virtual threads can you also have a builder pattern. In fact, I showed it to you just a minute ago. But if you want to add your own name to your virtual thread, you also can call this of virtual factory method. It's a kind of a builder. Well, it is a builder, in fact. And you can set your own name if you want to name your own virtual thread. This will work the same. How many virtual threads can we launch? So this is the exact same code as the one we ran just a few minutes ago. Okay, the difference being now we are launching virtual threads instead of platform threads. Okay, so if I launch just 100, how much time do I? Yeah, that's 2 seconds. Well, I don't have much overhead. Let's put 1,000. It should not take more than 2 seconds. Well, it's still 2 seconds. 10,000? 10,000, we began to see the overhead on the platform threads, right? Yeah, 2.9, not too bad. 100,000? We can just give it a try, right? 100,000, we were already down with the platform thread because we stopped at 50,000. And it took something like, how much was it? 40 seconds?
20 seconds.
Sorry? 20 seconds. Okay, so that's 5 seconds for 100,000.
If you increase heap, it's interesting. The heap size.
We wanted 1 million, right?
Yeah, probably where the GC, etc. That's why it's a little bit slow also. So if
well, you have overhead, yes. But the idea is that at 1 million, I know that platform thread, I can't do it. My machine will crash. Oh, I can hear the fan. Anyone has coffee that you want to keep warm? Because I could put it on my laptop if you want. Sorry?
there is a thing to dump stake, right? Should be in your
Which one?
to dump the stake. I think in
Sorry.
in GID you can dump the stake. I think.
Oh, yes, no, you don't want to do that. Are you sure you want to dump a stack of 1 million threads? Yeah, well, will you do that on your laptop? I don't want to crash mine doing my demo. Okay, 40 seconds. 40 seconds for 1 million threads. So clearly on such a laptop, 1 million threads is too much because 40 seconds is still a lot of overhead, but at least we could launch them. That was not possible with platform threads. Okay. And you can see that if you stay in the range of like 10,000 threads, it's just working.
What's a virtual thread? Just a thread in a pool, right?
We are going to see that. No, it's not a thread in a pool. It's not a thread in a pool. Should I show that to you? Yes, I'm going to show that to you. So this is basically the same code as previous one. I'm just launching 10,000 threads. And because I love regular expressions, I just created a regular expression. I'm going to dump all the names of these threads. I'm not going to do it with 10,000 because it's useless. I'm just going to do it with 1,000. Okay, so I'm just gathering all the names of these virtual threads. And what I want to do is just check if all have been created on top of the platform threads of this fork join pool I just showed you, and how many platform threads Loom created in this stuff. Okay, and I'm also displaying here the number of available processors I have on this laptop. So let me run that. Okay, didn't take too much. So I have 12 cores on this laptop, not bad. 32 gigabytes of RAM. It's a good laptop. Okay, it took 2 seconds to run these 1,000 threads. There is only one fork join pool for all my computations, and only 9 platform threads. Okay, so all these, how many did I do? 1,000, I think. Yeah, all these 1,000. Yeah, 1,000 virtual threads. So all these 1,000 virtual threads were run on 9 worker threads. So Loom is just adjusting the number of platform threads according to the number of processors of cores I have on my machine. Yeah?
One question related to the coding. Can you show the code itself?
Yeah, sure.
Usually, if there is an interrupted exception, you should mark your frame as interrupted.
Yeah.
Like this part is here, it's like your referring exception. It's specifically for dumb virtual thread because
No. No, it's just because of the sleep method is.
Yeah, but there's an interrupted exception in like there's a best practice programming practices.
Mhm.
You should, in this catch exception, because you should do thread current thread interrupt, like to mark your thread is interrupted.
Yeah, but this exception is not thrown, so I don't really care.
Okay. So I want to use it like, I mean it's best practice to mark your thread as interrupted in old way. So that's why I'm asking, is it changed?
I don't think you care because this thread is almost free. I mean, you can create just 1 million of them.
This one I'm asking because.
I agree. But I mean, in that case,
Okay.
whatever. Okay, so you see that sorry. With this Loom stuff, you can have many virtual threads. I mean, I wouldn't say that they are free, but they are much cheaper than platform threads, like not probably close to 1,000 times cheaper. Okay, so you can create many virtual threads without any problem. And Loom is handling the fact that one virtual thread can run on top of a platform thread and can be removed from this platform thread to leave the room for another thread. This is basically how it's working. Yeah? It's about 1,000 times less. It depends on your stack, but it's about 1,000 times less than a platform thread. How many virtual threads can I run? Okay, I showed that to you. The virtual thread will basically be created, in the order of microseconds, where a platform thread is created in the order of the millisecond. It can grow and shrink the stack dynamically, and we're going to see that in a minute. Okay, and it uses this specific fork join of platform thread. So how is it working under the hood? Okay, it's all working on a concept that I'm going to show you, which is called the concept of continuation. So I'm just going to switch from this guy and show something to you. So here I have a bunch of platform thread. Okay, you know what? I'm going to make them virtual thread directly. Do I have it? No, I don't. I'm going to make them virtual thread directly. It will be easier. Okay, and what I'm saying is that for a given thread, I'm creating 1,000 of virtual threads, and for the thread number 10, I could have chosen any kind of other thread. I'm going to just print the current thread. Okay, and put this thread to sleep and increment the counter. So if I run this code, it's pretty easy. The counter at the end should be 1,000. Let us check that. Okay, it took about a second to run this code, which is fine. Now, what I'm going to do is after the sleeping, I'm going to print the thread again, because you see that here I have both the number of the thread and the number of the worker thread that is running this thread. And in fact, I'm going to do that several times. So I'm going to put it to sleep once again. Okay, 1, 2, 3, 4. Okay, 4, that should be enough. Okay, so sleep. That's 4 seconds of sleep, and every time print the virtual thread, the thread it is on. And what you can see is that it starts on the worker thread number 11, then it's put to sleep, then it's running again, but not on the same platform thread. That's a 3, put to sleep, running again on worker thread 5, put to sleep, etc. So a virtual thread can be moved from one platform thread to the other by the framework, by Loom itself. Okay? How is it? I'm going to show you. I'm going to answer your question, whatever it is. How is it working under the hood? Well, you can check the tree. Oh, come on. No, I don't want you. Theme reader. I don't even know what it is, really. Oh, it's for Windows XP. Great. That's a cool feature. So I want to show you the thread class. This is the thread class from Loom and the sleep method from this thread class. Gosh. Okay. Hey, can you stop doing that? I want to see the sleep method. Yeah, this one. Okay, so this is the sleep method from the thread class from this Loom distribution. What you have here is a first test if the current thread is an instance of virtual thread or not. And if it's not, then it's just executing this code, which turns out to execute this code, this sleep0 code, which is some native code there. Okay, so that's the classical way of putting a thread to sleep outside of Loom. What is happening there? It just calls sleep nanos on this virtual thread. Okay, and here it ends up calling do sleep nanos. Now the first part, thread sleep event, is a Java flight recorder part, because you can create events with JFR when you're putting threads to sleep. So let me follow this method. This sleep nano, I'm in a private method, and I'm in the virtual thread class. Okay, this is the virtual thread class here. It's calling try yield here, and park nano there. And trust me, park nanos end up calling the same code. Try yield, I'm still in this thread class, is calling yield continuation. And now I'm in this special object. No, I'm still there, sorry. Yeah. And here on the middle of this code, I'm still in a virtual thread class. You have this call to continuation.yield. Okay, and this is where the magic happens. Magic happens. What is this continuation.yield really doing? Let me show that to you on another example. This is this one. Here I have a continuation. So you cannot play with continuation because continuation is a class from the JDK internal VM package. Okay, so it's a closed module of the JDK. First, it begins by JDK. This is not for us. Second, it's internal, so it's completely hidden from us. Okay, you just need to add the right stuff when you load in JVM to be able to get a reference on this class and play with it, which is what I did. You need to add that to your JVM to have access to this class. So here I have a continuation. It's built on a scope. Great. And you pass a runnable to it, and this runnable will execute. Okay? And what I'm doing here is I am printing start on the main thread. So this code is not doing anything, right? It's just the creation of a variable of type continuation. It's not executing anything. Then I'm calling run on this continuation. And this run call will begin to execute the runnable within the continuation. So I will see C1 with the thread being executed there. Okay? And then there is this yield stuff. And this yield stuff will suspend the execution of this piece of code there and give the hand back to the main code, okay, that is there. So I will first see C1 and then came back. And if I run this continuation again, it will continue running after the yield. Okay? So if I execute this code, you can see that everything is happening on the main thread. So I'm not doing any kind of virtual thread concurrency whatsoever here. Everything is happening on the same thread. And this is how continuation are working. First, I execute this continuation because I called run. So this is the start, then the run. Then the yield gave the hand back to the main code. Okay, it's just like a return, but without the return from within the middle of a block of code. All right, and then after that, I called run again. So it continued to run the continuation where it left previously. And I have C2, etc., and then done. Okay? You already saw that in Java? No, you never saw that in Java before, because you cannot do that. Sorry? I don't think you can do that in Kotlin either. Well, not in the same way, that's for sure.
No, not exactly the same. But
yeah. Okay? What it did really is this stuff. It worked like that. I'm calling start. Here I did it with sleep there, because I have a continuation.sleep within the code of the sleep method I just showed you. All right. So when I call sleep here, this yield continuation.yield is called, and what it does is that it takes the stack, the call stack of the piece of code it is in, and it copies this call stack somewhere in the memory, basically in a heap. Okay? And now this platform thread is free to do something else. It's free. I just detached the task from the platform thread, something I couldn't do in Java previously. All right? And when this run stuff is executed again, so continuation.run, then it takes the stack back from the heap, put it on the platform thread again, and resume the process.
It's Java heap or special memory region?
No, it's the heap. It's the heap. It's the heap. Okay? And in doing so, and this is what I showed you. You see, when you put a thread to sleep, you can see that it jumped from one platform thread to the other. Because in fact, it doesn't have to put this stack back to the same platform thread it was on previously. By the way, it doesn't know from which platform thread it comes from, so it can't do it.
What's the overhead of copying it?
There is an overhead. The overhead is the microseconds you saw in the overhead of the handling of the virtual threads. So it's much lesser than moving a platform thread from one call to the other or switching context or this kind of thing.
So why is the main thread stack?
Sorry?
Is the main thread stack? Is that also in the heap or somewhere else?
No, the stack is the stack. It's a special piece of memory where the stack is stored.
I thought in Java stacks are also in heap, right?
The stack is in the stack and the heap is the heap. The heap is where you allocate your memory. Okay? And so if you rerun, you can in fact jump from one thread to the other. The code I just showed you there, I was in a main thread, right? But if I do the same kind of thing in a concurrent environment, it will you will see that will jump from one platform thread to the other. Okay? Actually, I could show it to you there. So here, I have a bunch of continuation. I create 10 continuations. All right? I just create them using this web pattern, and I basically have the same code there that the one I showed you in the main method just previously. Right? So here I'm just, what did I do? Yeah, great. So basically I'm just displaying the number of the thread, then I'm yielding the continuation, then print the number of the thread again, then yield the continuation again, etc. And I'm going to do that in a multi-thread environment. So I'm just creating a virtual thread there. This is the piece of code there. Each continuation will be each continuation there will be executed in its own virtual thread. All right. I launch them, join them. This is step 1, and then do it 3 times because I have 2 call to yield, so 3 parts of the code. And if I run this code, okay, the execution is this one. So I have this is the first execution of the first part of each continuation until the first call to yield. Okay, that all these are the number of the continuation. So if I want to follow A11, for instance, you will see that A11 is first running on worker 2, and if I follow it to B11, B11 is now running on worker 10 because the run put the stack on another platform thread, which is fine. And if I follow C11, which is the same continuation, it's now on worker 6. All right? Yeah? Sorry, you need to speak a little louder because I cannot.
So, as far as I remember, the stack doesn't have an instruction pointer. How does he know where?
But it's in the stack. That's precisely the stack. What the stack is about. The stack is just the number, the element that have been called from the virtual thread. So from the run stuff, you see, from the start stuff up to this is your instruction there, okay, and this is the instruction that launched the virtual thread. So it's put on the top of the platform thread. So all the whole stack is the platform thread plus the virtual thread, and only the virtual thread is saved on the heap. And it can also optimize stuff. So if he sees that the stack in the virtual thread doesn't change much, it can optimize There's an optimization that can be applied there. Okay. So this is basically how continuation are executed. I just showed that to you, so I'm going to pass that. All right. So in a nutshell, a virtual thread is just something that will carry a task. You still have this strong dependency, strong link between the task and the virtual thread. But once you have that, a virtual thread can jump from a platform thread to the other. That's the model Loom is basically implementing. Okay, a virtual thread only consumes an operating system thread only if it has some calculation to do. All the JDK, I think that's the next one. Oh, sorry. All the JDK, well, most of the JDK, I don't know if all the JDK has been refactored, but most of the JDK has been refactored so that every time a thread is blocking, there is a yield that is called, allowing this virtual thread to be removed from the platform thread to leave room for another virtual thread. Okay, so if you check NIO, for instance, Java NIO, sockets implementation, everything, in Loom, everything has been refactored to leverage this possibility. And of course, thread.sleep also does it. Well, thread.sleep is easy because it's so easy to use it for demos. So this is why I'm using that. But if you check the code of Java NIO, you will see that you have this call to continuation.yield all over the place. So it's doing the same. So basically, in a nutshell, creating a virtual thread, I wouldn't say it's free because nothing is ever free. It's cheap in the sense that it's about 1,000 times cheaper than creating a platform thread. So you can create really many of them, both in performance and in memory consumption, right? Blocking a virtual thread is also cheap. Why? Because blocking a virtual thread means yielding a virtual thread. So Loom can just take it out of the stack and leave room for another virtual thread, which is awesome. So we reached the conclusion, do you think it's really worth it, pooling virtual threads? You are just going to write some complex policy to pull your virtual thread, and it's going to be useless. Okay, so pulling virtual thread is just not worth it. So if you consider concurrency, like executor service and this kind of thing, you always have two strategies when you're doing concurrency. The first one is competitive concurrencies. That is, all the threads are going to compete for the CPUs and the core of the CPUs of your machine. Okay, and a cooperative one, which was working really great back in the days of Windows 3.11, where once a thread is done on your CPU, it should say, okay, I'm done. Now I'm releasing the CPU so the next thread can have it. Okay, and if you forgot to do that, you need to reboot your PC, basically. This is what happened back in the days with Windows 3.11. And in fact, Loom is implementing both. There is a thread scheduler that will schedule the virtual thread among the platform threads. And there is the handling of the platform thread, and the idea is to never touch them. You put a platform thread on the core of a CPU, and this platform thread will not move. No context switching, no removing, no reinstalling whatsoever. It will just save a lot of overhead, having the right number of platform thread as the number of cores you have on the CPU. And by the way, the demo I showed you, there were only 9 platform threads for 12 cores. So the other cores are free to do other things.
Just one question. In Linux, you can change the scheduler.
Yeah.
Is it possible, or is it planned to be able to configure different scheduler based on the workload?
So the question is that in Linux, you can choose the scheduler you want to schedule your platform threads on the core of the CPUs. Here, well, you can try to rewrite the scheduler of Loom that is handling the virtual thread among the platform threads. In fact, it's written in Java. The copying of the stack is written in C, but the scheduling of the virtual thread is written in Java. So if you want to look at it, and if you think you can improve it, or at least improve it in the context of your application, you can definitely do that.
Okay, for now, we have only one
I don't think there are many, there are more than one scheduler. Yeah, I think there's only one. Maybe in the future there will be more than one, I don't know. Okay, and that's precisely it. In fact, most of this virtual thread stuff is written in Java in the JDK. This continuation class is a Java class. All right. What has been done in what is written in C, I just told you, is the copying of the stack from the stack itself to the heap back and forth. And also, many things have been done because when you have garbage collectors that needs to look at the stack and the reference you have in the stacks, but now they need to go and fetch stacks elements in the heap, which was not the case before. So the effort Loom implied in the JVM and in the JDK also included the rewriting of all the garbage collectors, basically, at least pieces of them. So it was a huge effort, as I showed you. Which one? The garbage collectors one? A garbage collector needs to look at the stack to see if you have references to objects, because it needs to detect if an object is referenced by something or not. Okay? Before, now, currently in the JDK, these references are on the stack, and they will give you access to the elements of the heap. But now, pieces of the stack may be moved to the heap. So when the garbage collector is launching, it needs to look at the stack, but it also needs to look at the pieces of stacks that may be stored in the heap. Okay, so this is something they didn't do before. This is something they are doing now for Loom, because they need to do that. Just that. So in the JDK, all the blocking codes are changed to check if the current thread is a virtual thread. We just looked at the sleep method. All right. If it is a virtual thread and this thread is blocking, then it will launch directly or indirectly a call to connect continuation.yield. And if it's not, it will just continue working as it is working as of now. All right. So that was also a huge rewrite of many APIs, especially the I/O APIs within the JDK, but not only in these APIs. Also, some of the synchronization APIs. Now, there are cases where it doesn't work, where a virtual thread is pinned on a platform thread and cannot be moved. And this case, yes, it's bad news. Sorry, I'm also bringing bad news to you. And this case is when in a stack you have code that is not Java code. That is a call to some C code. Why? Because in C, everybody knows C code, right? If you have an int, for instance, you int I equals 0, and it's a local variable declared in a function, you can get the address of this variable. You can do and I, and this is a number, an integer, that is the address of this variable. And it's an address on the stack. Okay? So if you store that somewhere, and you begin to move the stacks everywhere, then this address will not be the good one anymore. You will not find your variable at this address. So if you have C code on your stack, in your virtual thread, then this virtual thread Loom will not be able to move it, basically. So there was also, and I can show it to you, by the way. I'm going to show it to you in a minute. And there are many places in the current JDK, JDK 18, that is currently in production, or 17, where you have native calls. So these native calls, wherever they are, they need to be removed from the JDK to make place from Loom. All right? And there are many places. There's one place where it's very annoying to have a C call, which is synchronized. There is C code in synchronized. Oh no! So how is it going to work? I got an example for you. Where is it? Okay, it's this one. It's always the same example, all right? I have a thread that is virtual, unstarted, and then I'm going to increment this counter in a synchronized lock. Okay, and because this thread is synchronized, if I display, what do I display? If I just display the virtual thread and the platform thread that is going to be executed. I have 1,000 here. Let me do that. And you will see that it's always the same. This virtual thread is always running on the same platform thread. It cannot be moved from one platform thread to the other because it's pinned, because there's some C code in this synchronized call. All right? Now, if I do this, if I execute the same code, and instead of calling synchronize, now I'm calling lock, which is from a feature perspective the same thing. But in lock, I do not have any C code. It's only Java code. So let me run this. Okay. Sometimes it works, sometimes it doesn't. Oh, come on. Okay, good. It jumped, you see? The first part was executed on the platform thread 2, and the rest on platform thread 5. So this virtual thread is not locked. Well, at least you saw it. Okay, you saw it twice. You could saw it jumping from one platform thread to the other. So it's not pinned on the platform thread. Yeah?
So how about if you wanted to have, because you can have thread affinity against the CPU core.
You want to have thread affinity between what? Virtual thread?
Against CPU core.
Oh, between a platform thread and this is not handled by Loom. I mean, Loom is on top of that. So if you want to have that,
Because you know like how the CPUs are at the moment, so they have registers. Right?
yeah,
So the memory gets put into the register and then you work with it, right?
yeah.
So you can actually have a core. You can actually have an affinity against a particular core.
To be honest, I don't know how it's handled by Loom. I need to ask that. Okay, that's an open question. Sorry, I'm not sure. If you have a specific use case in your mind because you need it in your application, by all means, just download this preview version and see how it behaves. And if you think it's not behaving in the right way, tell us. Go to the Loom mailing list and post a use case and explain.
The question is there, I mean, do they have API to ask, okay, this virtual thread I want to pin myself because I
Oh,
want to
what?
sharing, etc.
Why would you do that? No. You don't want to do that. No. You want to handle that.
It's about thread affinity against the core.
Yeah, I think I got what you said. No. If you have a specific use case in mind, I really encourage you to download this stuff, try it if you see if it's working as intended or not, and report it if it's not, of course. This is still a preview version, so there's still work in progress there. Yes, other question?
You said that IO code in IO was rewritten to support Loom. But what about the project reactor code?
Project what?
Project reactor.
Oh, Project Reactor is not part of the JDK.
No,
So
does that change affect the reactive code?
it does not. What I'm telling you is that a virtual thread is free to create, almost free to cheap to create, cheap to block. Why would you need to go asynchronous with that? You don't need it anymore.
Okay, but what about the existing libraries?
Existing libraries will still work. If you decide to put them on top of virtual thread, they will probably work better. You need to check that yourself. Now, if you're using a library that is using C code, and there are many libraries around that are using C code underneath, you may have problem, and this is what I just showed you.
And are there any downsides of using virtual threads?
Any downside on using virtual threads? To be honest, I don't see any. I don't see even the JVM is using them. Okay, so if it had any downsides, I don't think the JVM would be using them itself, and it does. I guess there must be downsides, but I don't know them. Maybe we'll discover them along when we use them.
Do you have any warning printouts when people taken from that deleted from native code?
No.
We can understand that.
No, you don't. You need to check yourself to see if the code you're having, does have native code in it or not.
Yes, but only we can use libraries where there will be some hidden.
Yeah, absolutely. Absolutely. I agree.
Even for synchronize, there is no warning.
It would be nice if they would supply a flag to log some warnings.
I'll talk about it. Maybe it does exist. I don't know. In fact, I don't know.
Also, I saw examples of replacement for the ThreadLocal.
Yes. Don't worry. We're going to talk about ThreadLocals. Okay, so this is the case where it doesn't work. Okay, so now you have a good reason to use reentrant locks over synchronized. And if you are using synchronized in your code and want to embrace Loom, maybe it's the right time to begin getting rid of this synchronized stuff and using reentrant lock instead. Now, there are efforts to rewrite synchronized with Java code instead of C code or assembly code, but as of now, it's not done. All right, so this is what I just showed you. Okay, there are many elements. I told you that the many elements of the JDK have been rewritten to remove these native calls, the C calls within Loom. That was the case for the legacy socket API. The biased locking was deprecated and removed because of that, because there was some C code in it. And I don't think many people really used it. There is, in the JDK 18, the core reflection, the method class, and some others were rewritten to use method handles instead of what they did before. And one of the reason is performance gain, that's for sure. But another reason is that in the invoke method of the method class, there was a native call in it. So it has been removed so that if you are doing reflection and using Loom, your code will not be pinned on a platform thread. Okay, and the same for this other JEP. So the idea under the hood, you can create as many virtual threads as you want. It's almost free to create them. The idea is to mount a virtual thread to an available carrier thread, and this is handled for you completely transparently. I didn't write any code to do that. This is handled by Loom directly. And if your thread is blocking, whether blocking because of synchronization or because it's waiting for some data over the network, then it will be unmounted from the current platform thread by this continuation.yield mechanism. And once it's done and once the data is available, it will be run again and put back on a platform thread. All right, that's the gist about Loom. Yeah? I don't think so. I don't think so. Yeah, I don't think so. Yeah, it's kind of the same question as previous one, because if you know that you have C code, you know that you'll be pinned. So yeah, but that's definitely a good question, and we'll ask around. And, oh, what about, you know? Okay. Thread dumps. I'm going to show you a thread dump later. You see one. What about ThreadLocal? Hey, you were on your phone. I'm answering your question. Okay, first of all, what is a ThreadLocal? The ThreadLocal is a hash map. Okay, it's basically a hash map. When you have 1,000 threads, which is already a lot, having 1,000 hash maps in your application is not too bad. When you have 1,000,000 threads, having 1,000,000 hash maps may start to become an overhead that you will see in your application. So maybe you don't want that. All right. You see that the problem with ThreadLocal is that you are tied to a virtual thread, but this virtual thread will be able to jump from one platform thread to the other. Okay, so it's clear that in this context, ThreadLocal will not work anymore. ThreadLocal are not working with virtual thread. Just don't do that. Now, you still need them. Okay, you still need them, and there is a new concept, in fact, that is coming, which used to be called ScopeLocal, and that is now called extent local. So if you find blog posts, articles, videos, whatever, about ScopeLocal, it's just the name of the extent local in a previous version of Loom. It's the same. It's almost the same. It's the same concept. It's not the same class because the name changed, but that's the same idea behind, just the name of the class that changed. Basically, an extent local is just a variable that you create with this first line of code. All right. And when you create a task, you can run this task in the context of this extent local and give a value to this extent local variable. Okay. If you call extent local where, you take the extent local variable you just created, which should be really a global variable in your application, at least accessible from several places. You give it a value, and the task you're going to run within the context of this extent local and this value will see this value of this extent local. So if I run this code, and you see that here I don't have any thread, right? I'm just everything is running in the main thread here. I don't create any kind of virtual thread whatsoever. But if I execute this code, you'll see that the first execution of the same task gave me value A for this key variable and value B for the same key variable in the other context. So that's the way ThreadLocal are refactored to extent local without any hash maps within the context of virtual threads when you have really lots of virtual threads. Okay. Now I think I have an example on with this guy. Oh yes, just the same. So yes, this is a messy example, sorry. So here I am just naming my runnable along with the value given to this. Sorry, is this the one? Yes, it's the one here. So I'm running this task in the context of this extent local there, giving it the value index here. And this index is read back within the task for each virtual thread. Does it make sense? Well, basically it's working. Okay, the code I just showed you is working even if you're running on many virtual threads. That's the gist. This example may be a little too complex, and that's it. All right. So this code with continuation.yield blah 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 just worked the same as previously. Instead of computing the number of the task every time, I just read it from the extent local variable. And maybe we'll see another example of that later. All right. And that's it for extent local. It's a pretty simple API, in fact. So that's the pattern of code I just showed you.
There is an inherited ThreadLocal, so there's again some kind of there's a ThreadLocal and inherited ThreadLocal, right, in GDK. So it's basically if you have thread and starting new thread, so it's kind of getting the ThreadLocal from the parent thread. Do we have analogy for virtual threads?
Sorry, I don't quite get your question.
There is an inherited ThreadLocal class.
Yeah.
So basically, the meaning of this, if you have parent thread that is starting new thread, so the new thread.
Oh yes, okay, yes, absolutely. We'll see that here. An extent local is not bound to any thread. Okay, it's bound to a task. This is the if you want to bind it to a thread, it will be terrible because you have so many threads. You can't do that. So it's really bound to a task, right? You run this task within the context, and this is a new task. This is a new runnable that you can run in any task in any thread.
So if I want to run a new task in my virtual thread, so basically I'm starting another where with the same key.
Yeah, I think so. We'll see an example of that when we talk about structured concurrency. Okay. So this is what I wanted to talk to you about virtual threads. I think I covered almost everything. All right. The next part is about structured concurrency. Okay, but what about we get a little coffee break before that? Okay, so thank you. Okay, so let's carry on. Now that we have this new virtual thread model in mind, that we don't care about creating, that we don't care about pooling, that we don't care about blocking, because all this is so cheap. It's not, I wouldn't say it's free because nothing is ever free, but it's really pretty cheap to do that. Is it okay if I close it here? Great, thank you. We are going to play on top of that because the goal of Loom is really to make asynchronous computing easier, right? And I'm going to show you examples. Well, we're going to work on a use case, basically, which is, I call this example the travel agency example. Okay, I guess you've all booked travels once in your life. Usually what you're interested in is the travel itself, and you need a quotation, and you don't want to pay too much, so you need several quotations, and you're going to choose the best one. And of course, the travel agency wants to tell you, oh yes, there is a very sunny beach there. You should definitely go there. It's just great. So it will just push informations to you that you didn't ask for, basically. Okay. So on this page, we have two informations. We're going to create this page, the quotation of the travel and the weather forecast for this destination, right? There's one information that is obviously quite critical, which is the quotation, because if there's no quotation, then you can't buy the travel. And then information that is not so important, which is the weather forecast. But all this is going to be queried on remote servers, so all this should be done asynchronously. What solutions do we have? Well, we have the first basic solution, that is the completely synchronous solution. You get the quotation, you get the forecast, the weather, you build a page, and you return it. Now, of course, you don't want to do that because every element of this piece of code will take in the order of hundreds of milliseconds, and on the overall, it will be far too long. But if you consider this example, it's a pretty good example. First, it's super easy to write, pretty straightforward. It's also very easy to read and to understand. Okay? And in fact, it works very well because suppose that the quotation is not working, that you have an exception in the getQuotation method, then the getWeather method will not be called. Okay? And you don't want it to be called because you cannot build the response page to your user. All right? So in that case, this is exactly what you want. If the thread that is executing the getTravel page itself is interrupted, then everything is automatically interrupted. If you are calling getQuotation, if you're calling getWeather, everything is interrupted at once. You don't need to do anything. And once again, this is exactly what you need, right? And if you want to do some debugging, we were talking about debugging just a few minutes ago. If you put a breakpoint in this code, wherever you put it, the stack trace you get gives you the exact information on where you are in your application. I am currently calling getTravel page, and I'm currently running getQuotation. This is my stack trace. So this code is easy to read, easy to write. It behaves well. It handles exceptions well. And it's easy to debug because you have a meaningful stack trace. Okay? Now the problem is that it does not perform well. This is why you don't want to write such code. And that's a bummer, in fact. I mean, really, because your CPU is basically not used when you're executing such code. Right? There was a 1 million factor between waiting and computing, so you don't want that. What is the executor service pattern if you want to handle concurrency yourself? You are going to create an executor service, submit getQuotation to this service, same for getWeather. Now it's much better because you will wait on the two get method at the same time or almost at the same time. So this code performs much better than the previous one. It's all asynchronous. It's handled by the executor service. But if you consider the question we ask ourselves, okay, so if getQuotation fails with an exception and you're already running getWeather, well, getWeather will consume some network resource, memory, computing power, everything for nothing because you're not going to do anything with the results, which is a bummer considered compared to the previous example, to the previous way of writing this code. Okay, if the main thread of getTravel page is interrupted and you already launched getQuotation and getWeather, well, those two methods are still going to run because they are in another thread and they don't know that your main thread has been interrupted. Okay, so you're still spending resources, memory, CPU, etc., for nothing, because in the end you know that you're not going to build the page. Okay, so this code has advantages. Well, has one advantage over the previous one, which is performance, but it has also many disadvantages, and probably on the average it will be more costly to run such code than the previous one. And as far as debugging is concerned, what are the stack traces you may have in such a code? Well, I just made the test, and here are the stack traces you have. All right? These are the same stack trace for the code written in a slightly different way. But I put my throw new exception, blah, 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 at the exact same location of the code. Right? The first code, you see, is get travel page $0. This is the first lambda expression of this method. You need to know that if you want to debug that. It's not really explicit, is it? And this one is the same, but this lambda was written in a static stuff. And this one is exactly the same, but this time it was not an explicit lambda expression, it was a method reference. And you don't even know you're in this method reference. It's not in a stack trace. So the stack trace, if you have an expression, if you have an exception, the stack trace will not be super helpful to you. Well, at least you need to understand stack traces very well to get any information out of them. So that was for the executor service pattern, but I think we can do even worse, like much worse, with the completion state pattern. So the first step is almost the same as the previous one. You don't create this executor service explicitly because you have this fork join pool that is going to be used by completable future. You just apply async. It's almost the same code, basically. Okay, and then when you get the result of the quotation, so the quotation completable future, you can compose it. And when the quotation is available, compose it with the weather completable future to apply quotation and weather to build the page. How did you put it? Just at the beginning of this talk, it needs training to write this kind of code. Do we agree on that? Oh, but it can become even worse. Don't worry. Okay, so if get quotation fails, and you want to make get weather fail, then you can do it because you have the future. You can cancel the future, but you need to write this code by hand, right? So you probably need to write this kind of code. If quotation fail, exceptionally, then cancel the computable future weather. So you can do it, but it's even more layers of how to read code, right? If get weather fail, you can handle the exception with a default value, for instance, which is nice because the weather is not a critical stuff you want to display to your user. Okay, and you do it that way. If you want to add a timeout, I just commented the code, but you can do it in that way. And the same for this is recovery on exception, the mechanism that is given to you by the completion stage API. Okay, so it's just 2 lines of code to add. So at the end of the day, this is the complete code to build the page with proper error handling. It's not very easy to read. It's not very easy to write. And if you want to maintain that code, then you'd better call the guy who wrote it in the first place, because understanding that code when you didn't write it, or even if you did write it, but like 2 weeks after that, it's going to be quite hard, I think, right? So yeah, this is not great. And if the get travel page is interrupted, then you cannot interrupt get quotation nor get weather. So this last element is still an open question because you would like to do that. And what about the stack trace? Oh, yeah. It's not so great, but you can. All these methods are also can also take a specific executor service. You want to do that, so you can. Yes, but it's add more complexity to this code. I absolutely agree with that. This is in fact a simplified version of the code, right? I agree. What about the stack trace in this case? The stack trace doesn't give you any information on where you are. Okay. Have you called Get quotation, get weather. Are you building the page? You don't know. You have an exception, and that's it. And this is the simple use case, all right? Because in a real use case, what you really want to do is your travel agency, you don't want to query just one server. You want to query several servers, probably both for the weather forecast and for the quotation. And you want to take the best answer from the 3 quotation servers, okay? So you have a use case that is simplified and a code that is already super complex. Okay, so structured concurrency is really about simplifying this kind of code. And this is what I'm going to show you now. So, okay, I'm going to switch to the IDE. Did you have enough slides, or do you want more slides? Okay, no one wants more slides, but that's a good idea because today I'm tired of the slides. By the way, there's something I forgot to show you. I'm just going to show it to you because someone asked the question about how to refactor a regular application code to a Loom code. And there is also something you can consider using, which is, sorry, I'm not on the right stuff, executors with an S. Thank you, because the interface is interesting, but not that interesting. Yeah, you have an executor service that will launch new virtual threads on demand. And it implements the right interface. So if your application is built on top of an executor service, or if you have an application server built on top of that, and you can give your own executor service to it, you can just switch to this executor service and see how it performs specifically. Great. So let me go back to this travel page example. So this is my travel page. This is the fully synchronous, super fast, no, not super fast, but super simple and quite good way of running it. And now I'm going to make it asynchronous using the APIs provided by the Loom project. So we're going to begin with this read weather. So this weather is a record. Everyone is familiar with records? Okay, great. That's just awesome. I'm going to create a scope object in a form of a structured task scope of weather. Okay? And this structured task scope is a class from Loom. It's not an internal class, so it's really meant to be used in your application code. And this scope is going to handle all the virtual threads and the concurrency for you. So you never, in fact, well, you can do that, but if you want to write asynchronous code, you never have to interact with virtual threads directly. You will only interact with this object, and that will be enough. By the way, I am going to use a specialized version of this structured task scope, which is called shutdown success, and I'm going to explain that to you in a minute. Okay. First thing you need to know about a scope is that it is an object that you need to close at some point. So I'm going to use it in a try with resources statement, because I like try with resources statement. Okay. So that it's automatically closed for me at when I exit this block of code. And I'm going to copy this. And the first thing you can do when you're dealing with scope is called the join method of this scope. Join method is kind of the same as the join method of the thread class. It conceptually does the same. And it's good housekeeping to call it right now, because within the life cycle of the scope, there is something that is happening before and something that is happening after. Okay. What I'm going to do before calling this join is I'm going to fork tasks. Okay, just like that. This is a runnable. I'm not sure, it's probably a callable in fact. Yes, it's a callable, sorry. And this is how I am going to submit task to this scope. And once I'm done doing that, I'm going to call result here. And it will return me basically the result of the execution of this runnable. Okay, it throws an exception. Does it? It does. Yeah. Yes, I want to catch it. That's fine. That's good enough. And this is what I'm going to return. Okay? So this is the basic pattern on how to use the scope object. Pretty simple. I can run my code again. And you can see that it's just running in the same way. Nothing new here. What I can do is, in fact, launch more than one task at this one. I'm not going to do it in that way. I am going to add some randomization to it. Okay, because remember, what I want to do is launch my query on several servers at the same time. I'm not going to use a server, of course. I'm just going to put this thread to sleep. No.
Just interesting, because random is kind of synchronized. They removed, I guess, the synchronization from random.
Is it?
I think next double.
I don't really, it's not important. I don't care. I don't care. We are not talking about performances here. I'm just randomizing stuff. And what I really want to do is say, okay, this first server is going to provide an answer after, let's say, 30 milliseconds and 110 milliseconds. Okay? And I'm going to put the result in a future object, because this is what this fork stuff is returning me. So let me get this future object, and I'm going to call it future1. Okay? So I'm going to suppose that this server is, well, providing me an answer, a response after a while, and I'm going to query 3 servers, future2 and future3. And they're not going to go at the same speed. This one can go a little slower, but can be also a little faster. Let me put it in that way. And this one can be faster, but it can, well, maybe be not as fast as the previous one. So now I have 3 tasks run concurrently with I think what is a really simple pattern, because I'm just passing callables to this scope. And this scope is going to give me a result, okay? And if I check this result, you'll see that this result will change. Here, sorry, here it's WA agency that has answered. If I run it again, oh, still WA. Come on. Oh, I didn't change. Thank you. Oh, yes. Well, that makes sense. Sorry. Okay, I'm going to call them A, B, and C, because it will be easier to see the result. Okay? Let me run this code again. So it's going to change at some point. Well, that's unfortunate, because it's outside of the window. Yeah, okay, there will be, obviously. So what is this shutdown on success doing? Is that it will just return me the result of the first task that is producing a result, and it will cancel all the others for me automatically. Okay, so in fact, here there's only one task that will complete, the fastest one, and the other one will be interrupted, which is great. I don't have to write any kind of code. It's just working like that out of the box. And we can see that because what we can do is, once this join call has returned, I have the guarantee that all the tasks that have submitted to this scope beforehand have finished their execution, either normally or exceptionally. Okay, so now what I can do is call this and see the state of this future. This state method is a new method from the future interface. It gives me the state of this future, which is great. And I'm going to do it for A, B, and C. A, B, and C. And you'll see that depending on... Could you run, please? Yeah. And you'll see that depending on the task that was the fastest one, okay, here I have 2 successes and 1 failure. Okay, meaning that the scope was not fast enough to cancel the B task. But if I run it again, maybe, yeah, here I have 1 success and 2 fails. So you can see that really the fastest task has been taken into account and the other have been cancelled. That's what you would want to do if you were querying a DNS, for instance, a domain name server. You just want the first result and the other are supposed to be the same. Okay. So this is how this stuff is working. Now I can go one step further with this scope join with this scope, because I also have a join until method that takes an instant as a parameter. Okay, and I'm going to say, okay, I want the result, but in 100 milliseconds. Sorry, and I'm going to make it a duration, by the way. Can I? Do you take a duration? Oh, temporal amount. Yes, that's fine. Temporal amount. So how can I create you? You know what? I'm going to skip that one because I can't remember the exact pattern. So it's going to be plus millis and 100, and this guy is going to throw a timeout exception. Okay. So I'm going to catch this timeout exception, and in fact, if I time out, what I want to do is close this scope. No. Oh, I can do it from here. Okay. It doesn't. I'm going to return, did I create a default weather? No. So I'm going to create a new weather with no agency and mostly sunny, because I don't want my customer to run out of my website. So yeah. I'm pretty sure that at this period of time it will be sunny.
But it's strange, because with resources things, it should close your resources, even in case of exception.
So here it has closed. Yeah, it has closed it because I was out of this stuff. So it's not. It has not been closed because of the thrown of the exception, but because I went out of the stuff, the try with resources statement. Okay, but if I can also do it in here. You see. Actually, let me do it in that way. Okay. Now it's not shutting down the scope anymore, so I need to shut it down by hand. Okay. So let me do it in that way and run it again. Now what I can do is, what I would like to do is say, okay, this join until method, I don't want it to throw this exception anymore, and I want to this result method to return a default value if the scope timed out directly. To do that, I need to change the behavior of this join until method, and we all know that to change the behavior of a method when you're doing object-oriented programming, what you need to do is to extend the class and override the method, right? Well, the only problem is that this shutdown on success method class, is final, so you cannot really extend it. So how can you override the behavior of method when you can't extend the class? Well, you just need to find the answer in the first page of the Gulf. You just need to wrap it. All right. Yeah. So what I'm going to do is say, okay, I'm going to create a class, not there, but here, private static class. And this is going to be my weather scope. Okay, and I'm going to create a field in it, private scope equals new this stuff, and I can get rid of this because I don't need it. Okay, and now this is my scope, so this is my new weather scope. Of course, it will not compile. Oh, how dumb I am, because I need to implement autoclosable. Okay, let me do that. Autoclosable, and I also need a fork method, a join until method, and a shutdown method, and a result method. By the way, now that I'm calling my own code, I could just call weather instead of result, because this is a weather scope. And this is my code, so I can do that. Okay, so I'm going to delegate this method, delegate method to scope, and what I need to delegate is join until, result I said no, fork, shutdown, and close.
There is no interface to
Nah, there's no interface here. Unfortunately, the only interface is auto-closable.
But this one you can be extended.
But you want to extend this structured task scope anyway, because there's a lot of code that you want to use. So this is probably the best pattern to use, really. Okay, so this join until is going to return this. I just need to fix this code a little. All right, I don't want you to throw this timeout exception anymore, so we'll have to handle it internally. This is just weather. So I want to get rid of this. This is a future of weather and a callable of weather, basically. And the rest is fine. Okay, now I want to catch this exception there. Okay, because I don't want I don't want my business code to handle it, basically. So I'm going to join until the deadline, and if everything is okay, I'm going to return this, because this is a contract of the join until method. All right, and if it times out, what I really want to do is say, okay, I had a timeout, so this is true. And then I'm going to create this field, set it to false. This return this should really be here. Fine. And in the, oh, I still need to implement. So this catch here is not needed anymore. So I can get rid of it. Up. And this weather method, I need it. So it's really a call to results. So if I didn't have any timeout, then this is a call to scope.result. Great. What you doing? Yeah, with the exception. And if it did timeout, what I want to return is weather.unknown. You should be. Oh, this is my unknown weather, and this is false. Okay. So now my business code is just this one. Launch the task, call join with a timeout, no more exception there, and just get the weather. Okay, you remember the previous code with the completion stage? That was not even doing that, that is querying 3 servers. And now I'm handling everything. And all the errors are handled properly. And if one of the stuff is throwing an exception, it will be handled nicely by the scope itself. So this scope object is in fact really the central object of the structured task scope API and of the structured concurrency model. All right. What about we go one step further? Do I need this shutdown stuff? I think I do need it. Oh, I forgot something, because this guy should really be called. So if the exception has been thrown, I should really call shutdown. Because if it has timed out, I don't want to do anything more. Now, this is very interesting, because if you want to do that, you could have a first bunch of tasks that you want to launch within a certain amount of time. This is the join until stuff that is telling you that. But after that, if you want to continue using this scope with another task, suppose you have 3 servers that are cheap servers, but you may not have the result fast enough. Then you can give another try at a more expensive server over like 50 milliseconds to have 150 milliseconds on the overall. So you can add more forks after this join until and another join until if you want. So you don't need to shut down the scope right after the within the join until. If you want to do that, you can do that, but you don't need to do that, really. All right. Is this code still working? I think it is. I think it is. Where was I? Here. So I need to run this code again. So it should still be working. No, it is. Great. What we could try to do is put a little more pressure on this one to make sure that these tasks are going to time out. And you see that, yeah, I don't have any agency, and the weather is the weather is mostly sunny, which is my default answer. Okay, I'm just telling that the weather is unknown right now. Let me do the same for the quotation. Right, read quotation is also is also a record, just in this way. I'm going to create a scope that is also a new structured task scope. Sorry. You know what? It's here, right? Okay, and this time it's a new structured task scope of quotation. Now, do I want to shut down on success? Well, probably not, because what I really want here is all the quotations and only return the best quotation. And if I want to add a timeout, I want to make sure that I add only at least one quotation. So let us do that. Try with resources. Okay. Scope.join. That is going to throw an interrupted exception. Great. Yeah, I'm going to randomize stuff. Random equals new random, whatever it does. And then I'm going to fork pass callables, new quotation. This is the quotation from agency A. Great. I have one stuff too much here. Fine. I'm going to add the curly braces, add some randomness, say thread.sleep random next int between 30, well, 30 I said, and 120. Fine, and say that the price is going to be also random, next int between, I don't know, 80 and 111, 110. Okay, and do the same 3 times, because I can. This one will be slightly faster, but the price may be a little higher. Okay, and this one will be, either faster, either slower. And the price, how the price is going to be? Well, the price may be better, but it can also be higher. Let me put it in that way. Yes, 190 is a little too much. So here I have my 3 tasks. Launching tasks is almost free. It's just natural to do that. And now what I want to get is just scope dot quotation. Okay. Oh yes, thank you. Thank you. Okay, I just want to do that. So I'm going to do the same, but this time structured task scope is a nice class. I can extend it. Where is it? It's here. Okay, it's not a final class. By the way, it's extended by shutdown on success. So yeah, so I can do that. I'm going to extend this class. Private static class quotation scope extends, and I'm going to copy this, cut it, by the way. Okay, oh, no, not you, only that. Okay, and this is new quotation scope. And now because I'm extending stuff, it should work exactly the same. All right, and now what I want to do is say, okay, I need all the results of all my callable there and take the best one. So somehow I need to store the results within the scope. It's a very different use case than the previous one, right? To do that, I need to extend a specific method which is called handle complete. Handle complete is a callback on the completion of all the tasks that I'm submitting to the scope, right? You see, it takes a future, and then it will do something with this future. It's just a callback. And it's executed within the virtual thread that is executing this task. Okay? So what kind of code do I need to write in this code? Well, I need to switch on the state of this future and do something with it. Do I need that? I don't know. We'll see that. Okay, the state of this future can be either running, success, cancelled, or failed. Now, within a structured task scope, I have the guarantee that the state of this future should not be running. because I'm called when the task is completed, either normally or exceptionally. So running is really an exception, illegal state exception, and I don't want that. It shouldn't happen. If it happens, then there's something really wrong in my code. It shouldn't be the case. The interesting case is success. If the future is in success, then I'm going to say I want to keep the quotation of this future. So do something like quotations.add future. And then I can call result now, because I have the guarantee when I'm in this method that the future has completed. Result now is a new method from the future interface with Loom. And this quotation has the structure, yes, or Unicode set, certainly, of a collection of quotation. Okay? But I need to be extra careful. I need to understand very well what I'm doing. If I make it an array list, I'm writing, in fact, 2 bugs. The first one is that you need to understand that this quotation field is going to be initialized within the thread that is running read quotation, because this is where the new quotation scope is happening. All right? And this add method here will be executed within a virtual thread of this scope object. So that's called a race condition. This implementation here should be thread safe. If it's not, it may work, but not all the time. Okay? But now I also have the race condition on the reference collections itself. Okay? Because this reference is initialized in the thread that creates the scope and read in the other threads that this scope is creating. So either you put, the best way to put it is to put final here. But it's not final just out of putting final everywhere, as you can see sometimes in some applications. It's really, you need it. If you don't, yeah, absolutely. If you don't put it, you have a race condition. And race condition is about having random bugs, right? You don't want that in your application, as you know. Okay, so just be extra careful with that. And this is all I need for the moment. All right. If I'm in failure, then I will have an exception. And this code is kind of the same. It's basically exceptions, because I want to store this exception somewhere. And it's not result now, but exception now. And it will just return the exception thrown by my task. Okay? And I'm going to do the same there. Now, this exception now stuff returns a throwable here. So I need to have a collection of throwable. That's by API, and this exceptions field will be there. Okay? And the last one is, sorry, the cancelled one. So cancelled happens when this task didn't have a chance to execute itself. You submitted it, somehow the scope did not execute it at first, it did something before that, but then you shut down the scope, so this task did not run at all. So you don't have any result, you don't have any exception, you don't have anything with this task. So there's basically nothing you can do. If you want to trace that, you may create your own exception or log something, but basically there's nothing you can do. Yeah, question?
In case of interruption, it will fail?
In case of interruption here, if you interrupt this thread, it will shut down the scope, okay? Because the scope will get this interrupted exception, and it will just shut down nicely. Well, if you shut down the scope, you don't need all these results, do you? You're basically, either if you shut down the scope before getting the result, because you interrupted the thread that is running this stuff, then you don't need the result anyway. If you shut down the scope once all this has been executed, then it has been executed, you took your result, you shut down it because you're done with it. This is the normal way of executing it. Yeah?
Can you say a few words about the result now and exception now?
Result now and exceptional now, you should only call them after join. In fact, if you don't, you will get an exception. Because it's not like get. I mean, get is blocking and it's waiting until the task has completed. Result now is just getting the result if there is a result, and if there is no result, you will get an exception. Okay, but it doesn't wait anymore.
I assume that result now doesn't throw an exception in its signature.
It doesn't. It doesn't. An exception now, well, yes, it returns throwable, of course. Okay, so now that I have that, I'm going to implement quotation. Quotation should return a quotation, and this quotation is the best quotation within this collection. Well, that's very easy to implement. Okay, I'm going to take this quotation, call a stream on it, because the stream API is very good at extracting mins or maxes from collections, comparing quotation, and this is about comparing the quotations, and that's it. This returns an optional, so you shouldn't call the get method of this optional object anymore. What you should really call is or else throw. So if this optional is empty, you will throw an exception here. Okay, and if I run this code, it's already running nicely because, oh yes, Unicode said, come on. Get rid of that. Okay, this code is already running nicely, and I have agency A that answered with a quotation of 100, whatever. But now you need to ask yourself, is this quotation going to be always full? Will you have always at least one element in this quotation collection? Because if it doesn't, then you're going to throw this exception, right? You always throw. Is it the empty optional exception that you want? Well, if quotation is empty, it may mean that you have something in this collection of exceptions, right? Because it means that you never executed this branch of the switch. So maybe you did execute this one at least once. And maybe you want to do something with these exceptions. Well, fortunately, there is a very cool mechanism within the JDK, which is the suppressed exception mechanism. Suppose you have a bunch of exceptions in this exceptions collection, and you want to wrap them in one big exception, carrying all these sub-exceptions. Well, there is a mechanism for that. I'm going to create my own exception class, public static class, quotation exception. Sorry, I'm going to say that it extends. Can I make it extend runtime exception? Because I really would like to do that. Let's see if it's going to work. And I'm going to create this quotation exception there. New quotation exception. All right. And for all these exceptions that are in this collection, I'm going to add them. I'm going to add this code, okay? The main exception that I'm going to throw, I'm going to add them as a suppressed exception to this exception. Okay, I don't know if you know this pattern or this trick. It has been added in JDK 7 as part of the try with resources statement. And by the way, this is a nice method reference that I really should be using, I think. And this is, I can pass a supplier of exception there. So now, if I do not have any answer to give because my quotations collection is empty, I can throw all the exceptions that have been probably thrown by the tasks I've run. Okay. And by the way, if I want to do that, I can even put that in its own method called exceptions. Okay. I'm going to inline this code because I don't need it anymore. And now I have also a way, if I want to do that as part of my scope stuff, by the way, I should return that. Okay, if I want to do something with these exceptions, I can just call scope.exceptions and do something with it, like logging them or something. Okay, so I have both a result and the handling of the exceptions if there are any. I have both them, and I have that for the three while querying three servers. So you see that basically the pattern is the same. You just submit your tasks to this scope object, which is my object, and you just call join to make sure that all these tasks have completed, and then you call your business method there that will handle how you want to aggregate all the results you had.
Join is blocked, right?
Join is blocking, absolutely. Yeah, join is blocking.
You cannot make it asynchronous, like if it's completed, like only after this execute, like completable feature. Let's say, like,
no, you don't want to do that because here you need to gather all the answers. The thread that is going to execute that is going to be asynchronous. It's not asynchronous yet because it's called by the build page, but it will be asynchronous.
Probably he want also to be asynchronous. Let's say he's calling after he's getting completable feature with rotation after
Yeah.
he's doing his own job. So
We are going to handle that at the top level, above that. Okay. And by the way, yeah, sorry.
Could you explain the difference between the scope that we use now and the previous one?
Sure. So the previous scope was assuming that all the weather forecasts that you get are the same. So you just want the first one that is going to be provided to you, and the other one will be the same, so you don't want them.
That's not what I meant.
Sorry.
The JDK one, the shutdown on success.
Yes, this is
Structured task scope.
this is the policy implemented in a shutdown on success. It's a DNS-like policy. Once one task answered, all the others.
It cancels and.
Yeah, absolutely. This is what I showed you when I showed you the futures there. You remember? You had success, failure, failure, failure. All right. So the other were cancelled. Now in this scope, the policy is different. We want all of them, and then we have a policy to aggregate them in a certain way. Exactly, because the JDK doesn't give you that, of course. But what you can do now is also called join until, right? And I'm going to copy this and paste it here. And I don't want to throw this exception in my code, so I'm going to override this join until method. Let me do it here. Yeah, I want to override join until, and I don't want you. This is to return this quotation scope, because this is the policy of this stuff. So, yeah. And I want to return this. And I don't want to throw this timeout exception anymore. Okay. So let me just surround that with a try catch. So if it times out, what I can do is just shut down the scope. This dot shutdown. Okay. And then what it will do is that obviously, because I threw the exception, the timeout exception, there are still at least one task that is running, but maybe the two others have completed successfully. So my quotations collection will not be empty. If it is, then, well, sorry, let me go back again. Calling shutdown will automatically make this method return. Okay, so now I'm calling quotation. If some of the quotation have complete, if I had responses from some of my tasks, then they will be provided to me. If none of them answered because it took too much time, then I will have the exceptions with the cancellation of the tasks in my suppressed exceptions. Okay, so this is also a way to, I think, nicely handle all the exceptions you may have in this kind of context. Okay.
How you handle cancellation case?
Sorry, I'm just going to put 100 here. Sorry, the cancellation case, which one?
Cancellation case in this switch.
Oh, the cancel case. I didn't do anything. But if you want to do something, because it really depends on your use case, right? I mean, it's really your application that is doing that. Okay. I guess this code is still working nicely.
So in this case, you could come up with nothing in your exceptions and no answers. Yeah. So I mean, in the cancel, you may want to.
You will have, yeah, but the future would have been cancelled, so you will have the exceptions. You know what? Let me put a little pressure on this guy.
Get the exception, and it will call handle complete.
Let's see that. Oh yes, it will. It will. So lambda quotation, what did he do?
Actually, it doesn't have any surface. It's just a,
Yes, which is worrying me because it should. I think it should. Oh, if it no, because what was it? No, they were all in a fail state. Oh yes, but the fact that I called shutdown, maybe it didn't call handle complete because I shut it down. This may be that. I'm not sure. Sorry. If it did that, if the fact that you shut it down doesn't call handle complete anymore, then you're done. That must be that. I need to check that out. Sorry. Let me put it back here. Okay, so you see that this basically a scope object is an object on which you are going to submit tasks, and it will join and then produce a result. If you think about it, it's the exact same pattern as the executor service pattern. Executor service, you submit tasks to it. You have several methods, result now, no, not result now, but shutdown, etc. To shut down your executor service in a nice way if you want to do that. And then you will get your future. The executor service doesn't produce any result, but you will get your future and you will get your results through your futures. So you can see the scope object has been some kind of executor service, but on steroid, smarter executor service. Plus, it launches virtual threads, which is of course much better. Okay, but there is one big difference between executor service and scope. Is that executor service, you launch it when your application is launched, and you shut it down when you shut down your application. The life cycle of an executor service is the same as the life cycle of your application. This is the case in Java EE, for instance. Okay? Whereas here, the scope stuff is bound to the life cycle of the task I want to submit to it. I create it, submit tasks, get the result, shut it down, close it. And that's it. So this scope object is a short living object. Doesn't live for very long in my application. Okay, so it's much easier to handle because you're sure that you'll never have some kind of garbage in it still running, whatever. You close it, closes everything.
I guess it's not good to accept this structured scope as a method parameter and not here in general.
No. You need to no. Just use it in that way. Use it. I think that's I mean, this code is so much. The only stuff that is a little complex here are the tasks themselves. If you have complex tasks, yes, but you can still hide them behind methods, right? Factory method, private method, whatever, if they are really complex. But I mean, the pattern is super simple. Fork, join, get the result, and that's it. And it's also super simple to extend. Do we have the time? I think we have the time for to handle the travel page because it's also we are going to see other stuff on the travel page.
To write test for this.
Sorry?
To write test
Yeah.
for this. So,
Well, this is a method, right?
but it will run in the thread.
Yes. You're going to write a test for this?
It will run
You don't need to add some kind of ugly stuff to make sure that your test is executed in the right thread so that it has the visibility on the elements you get. Because what you're really doing is you're just returning the result from the thread that called this method, which is very different from the completion stage API or whatever. And much simpler. Much simpler. All right, so now this call is asynchronous. This one is asynchronous also. And we are launching 3 tasks on remote servers. The call to read weather and stuff is not asynchronous in itself. So let me do that, and I think that you begin to understand how this is going to work. So I'm going to create a scope specifically for this build page. So I'm going to call it travel page scope. Okay. Let me create this class real quick. Private static class travel page scope, and it's going to extend structured task scope. Now, I run into a first problem in this code, because here I need to give a parameter to this structured task scope. And on 2 examples we saw, all the tasks were producing the same object, either weather or quotation. And now we are producing a weather and a quotation. So I need to find a type that is going to be common to weather and quotation. And for the moment, the only type that is common is object, right? And I don't want to say, okay, that's the structured task scope of object. Wouldn't make any sense. So I'm going to say, okay, these are page components. So let me create an interface, page component. I'm going to put it in a model package because I like the model package. I'm going to add it to Git. I'm not sure what is this Git stuff anymore, so okay, never mind. And I'm going to say that my weather is implementing page component, and that my quotation is also implementing page components. Sorry?
This page component, I think it's from Wicked framework.
I guess it's pretty generic, so yes, you must be right. Okay, and now I'm going to do the exact same thing, called scope.join. Oh, this is core. Oh, one day I'll learn how to type on a keyboard. Not today. Okay, and now I can scope fork. This is going to be weather, read weather. Okay, and quotation, read quotation. That's basically it. Now I'm running asynchronously. Okay, the effort was huge, as you can see. And what I'm going to do is just say, okay, scope dot travel page. Because this is my scope, I can do whatever I want with it. And this is going to be my travel page. And I'm going to put this here and to get rid of this. Okay, so let me create this travel page method. Return null. Oh, I could have generated this return null. Whatever. And now, same as previously, the method I want to override is handle complete. Okay. So now I'm going to do the kind of the same thing as I was doing in a previous pattern. Oh, come on. In a previous pattern, I'm going to switch on the state of this future, and I'm going to copy some of the code because I feel a little lazy. Up to here. Yes, please. Okay, great. Am I missing this? I am. Okay, so in the case I have a success, I have in fact 2 kinds of future that can come back. Either the future of quotation, either the future of weather. Right? So I need to switch again. I need to switch on the content of this future, future.result now. And if it's a quotation, and you all know about pattern matching for switch, right? Well, that's a good place to use it. This quotation equal quotation. So I'm going to save that in a field. This field does not exist. Let me create it. Private quotation. This field should be visible. Remember, I'm not in the same thread, so this time I'm going to make it volatile. It could be an atomic reference, I guess. But today I like volatile. And I'm going to do the same for the weather. Okay, and say this weather equals weather. And this is going to be the weather field that is also going to be volatile. Okay, and by the way, because weather, I don't really care about the weather. Okay, if the weather is not there, if this switch is never called because there was an exception whatsoever, I can just take a default value for this weather stuff. I'm okay with it. And because this is a switch on type, pattern machine for switch, I don't want to write any default stuff here. So what I really should be doing is make this interface sealed. Absolutely. Thank you. Thank you so much. And just tell that this page component is a quotation or a weather. Okay, and now it's not compiling here because I have a problem with this IDE. This IDE is running Java 19, and it's an experimental feature. And within experimental feature, you cannot activate preview feature. So it's not compiling, but it's going to run, which is very confusing, but bear with me on this one. Okay, so if it's a failure, sorry, the case of the failure is also interesting because I have two kinds of failures. Either I have the quotation exception, and that's some kind of exception that is happening because something is wrong in my code or in the configuration of my application, or it's any kind of exception and I don't care about that. So I'm going to do the same. I'm going to switch on the future of exception now. Okay, if this is a quotation exception, and I'm going to use pattern matching for switch again, I'm going to say that this exception, sorry, yeah, it doesn't exist, so I need to put it by hand. Okay, this exception is equal to exception. And if it's not the case, and I'm going to use default, well, I really don't know what to do. I'm going to throw it. You know what? I'm going to do it in that way because if I don't, if it's a throwable T, I'm going to throw it. Throw T, and that's it. You're not happy? Oh, okay, never mind. Okay, I'm just going to not do. Oh, yeah. What I can do is just this: wrap it in a runtime exception. Runtime exception, so that I don't have any problem with this possibly checked exception. Okay, and I'm going to put that in a field there, which also should be volatile. All right. So that's the handling of all the cases of the quotation, the weather, and the exception. Okay. And if I want to return this travel page, well, either I have a quotation object or I don't have. So if I don't have, quotation is not null, then I can just return new travel page of quotation and weather. Weather will be either the default value or the value that was queried from the server. And if it's not the case, I'm going to throw this exception. If this exception is null, I will have a null pointer exception because throwing a null exception throws a null exception, null pointer exception. Okay, this should be probably made a little more elegant, robust, probably. Okay. Robust. I'm fine with it. Okay, but basically that's the gist. Okay, if I run this code, hopefully it should be working. And you see that it really handles the exception, the fact that you're calling different servers, that you're handling exception really at server level, etc. If you want to join until stuff, we can also yeah, absolutely. You mean continuation.yield, right? Yeah, absolutely. Sorry, where was it? I want to put this guy there. That's fine. And I'm going to override you like here. And the nice thing, I cannot really show that to you. Sorry, join until there. I think it's almost the same as the previous one, but never mind. Travel page scope. This is what you'll be doing. Great, and I don't want you to throw the timeout exception. Okay. I am going to surround you with try-catch. Super join until deadline. So if everything is fine, the exception is not caught, I will be returning this. If it throws the exception, what I should be doing is shut down this scope. And shutting down this scope will interrupt all the tasks, all right? And also shut down all the scope created by the threads of this scope. So the two other scopes from the quotation and weather will also be shut down. This is a feature you didn't have in the completion stage API, all right? Because here what we're basically doing is we're interrupting the main thread of the application, and interrupting this thread will also interrupt all the virtual threads and all the scopes that have been spawned by this thread. This is what structured concurrency is about. Okay, and that's a great feature actually. That's a great feature. All right, yeah, question.
Is there any way to change that? Like in Kotlin, you have the supervised scopes. You can actually play around with that.
You mean you would like to shut down this scope but let the other one running?
Yeah.
I don't think you can do that, but what you can do is restructure your code so that the subscope are not launched by this one. Do you really, does it, I don't think it makes a lot of sense. If you want to, in that case, if you want to shut down that, you don't want the weather, okay, or the quotation. So if there's something that you're querying that you still want within this context, it probably means that you should have put it in another context. I think so. What I would like to show you, I'm not going to run it for you directly because we're lacking of time. Do I have it on the slide? I think I do. Really quick. Yeah, Loom is great. You know that. Yeah, that's the magic command that will help you dump the threads of your application if you have a Loom application that is running. Okay, and you can extract it in a JSON file. And I'm going to show you the result of a JSON file because I ran this very application just yesterday, by the way. Okay, and this is the JSON file you will get when you have that. So here you have all the threads that are currently running in this JVM. Okay, so there are quite some of them. All right, and the Loom threads are the last one. These are, you have here, these are the thread flock. Okay, thread flock is the flock of the threads that Loom is, the structured task scope is creating. Okay, so the owner thread is the thread 25, which is, I think, just above that, or is it? That's the stack. You see, you can see the stack here, and you can see that you are on continuation.yield, park nano, blah blah blah, and read quotation 0, which is the reading of the quotation. Oh, I cannot shut you down anymore. That's great. Okay, never mind. So basically, you have all the structure here. You see the owner 23. We are going to find it. The owner of this thread here is 25, 23, and these are the first thread run by the JVM, and this is the first thread flock. So this is the thread, the scope of the travel page. Okay, this is the thread number 23, and the next one is owned by the thread 23, and this is the quotation. The weather scope, and the next one, which is also owned by 25, why so? I don't know. And this is the read quotation stuff. Okay, so you also have within Loom the possibility to dump the threads of your application, and all the scopes and stuff are there, and you know which scope has been spawned by what other thread and how things are organized. So all the information is in this JSON file for the IDE to update themselves once Loom is published, and so that they will be able to create panels in which you will not have to display a million threads and look for the one that you want to debug by yourself. Because if you're in this situation, you're in trouble. Okay. This is what I wanted to show you about structured task scope. I hope you liked it. I think that in the end, I much prefer this kind of code than the continuation stuff that the completion stage code that I just showed you about an hour ago. I hope you like this code too. If you have any questions, yeah, please.
Do you foresee the whole reactive stream style of writing code going away?
So the question is, do I foresee the reactive style writing a code running away? Going away. It really depends on what this code is doing, because once again, if you have pinned virtual threads, you will have trouble making this code really working. The situation is great when you have only Java code and no C code in your stack trace, in your call stacks. All right. So that's really something that you should keep in mind if you're using third-party libraries that are doing native calls. Then you may not gain much by using that. It really depends on your use case. But on the overall, I think that at least reactive code should really look into this and provide simpler patterns, because currently really writing callbacks using any kind of reactive framework is really a pain, I think. I think it is. Yeah. Any other questions?
I actually had a question with the earlier part of the presentation. So
Sure.
you have the continuation, right?
Yeah.
And if you, the example you have where if you call it again, it continues, right? So what happens if you did not have, let's say the code you have, a block of code, yield, and a block of code?
You cannot, remember, I just showed you the yield pattern just to explain you how things are working internally, but this continuation class, you cannot access it in a regular application. It's a hidden class. Okay, you cannot interact with it directly, and you shouldn't. Just let what do you really want? Yes, you can make this code more complex. Is your question, can I make this code more complex because I think it's too easy? Is it your question? No, you cannot interact with continuation.yield. I just showed it to you to explain you how it's working. But there's no magic. At the end, there's just Java code that is running, right? But it's really doing great things. This is what I wanted to show you. But no, continuation.yield is not a class that we would be allowed to interact with. Any other questions? Okay. You know what? Loom is great. Thank you.